number 19. Find at least two equations of straight lines in the family of lines y equals 5x plus b, for which b and the x coordinate of the point of intersection of the lines with 3x minus 4y equals 6 are integers. Given point of intersection, let us try to solve the two equations. The first equation is minus 5x plus y minus b equals 0. The second equation is 3x minus 4y minus 6 equal to 0. Multiply first equation by 4. I get minus 20x plus 4y minus 4b equals 0. As I add it, 4 by 4y cancels. I get minus 17x minus 6 minus 4b equals 0. That is, minus 17x is equal to 4b plus 6. X is equal to 4b plus 6 by minus 17. As I know the x coordinate which needs to be an integer, let us write the condition. We need b and x coordinate are to be integers. What do I understand? If this needs to be an integer, the numerator 4b plus 6 should be a multiple of 17, so that I can cancel 17 and get x as an integer. So b and x coordinate are to be integers, implying 4b plus 6 should be a multiple of 17. What do you mean by multiple of 17? 4b plus 6 can be plus or minus 17, plus or minus 34, plus or minus 51, and so on. Since b also needs to be an integer, consider only even multiples. Let me consider plus or minus 34, the first even integer, that is a multiple of 17 also. As I consider 34 and minus 34, rewrite the equation, I arrive at b value 7 and minus 10. In which case, x also minus 2 and plus 2, which are integers. The question is, x coordinate should be an integer as well as b value should be integers. Putting b value back in equation 1, I get y equals 5x plus 7 or y equals 5x minus 10, and these are the required straight lines of the family. Let us quickly rough through the problem. The given straight line, let me call 1, and for point of intersection with the other line, call it as number 2. To get the point of intersection, we are solving 1 and 2. Rewrite the first equation, second equation. First equation, as I multiply by 4 and I try to add it, I get x is 4b plus 6 by minus 17. The condition is this x coordinate should be an integer. This will be an integer provided 4b plus 6 is a multiple of 17. Since b also needs to be an integer, select only even numbers as we have got 4b here. Let me consider plus or minus 34, the first even integer, that is a multiple of 17 also. As I consider 34 and minus 34, rewrite the equation, I arrive at b value 7 and minus 10. In which case, x also minus 2 and plus 2, which are integers. The question is, x coordinate should be an integer as well as b value should be integers. Putting b value back in equation 1, I get y equals 5x plus 7 or y equals 5x minus 10, and these are the required straight lines of the family. Question number 20. Find all the equations of the straight lines in the family of lines y equals mx minus 3, for which m and the x coordinate of the point of intersection with x minus y equals 6 are integers. Notice the condition. We need all the equations. The given two lines, let us rearrange. Mx minus y minus 3, 0. X minus y minus 6, 0. Name them as 1 and 2. Point of intersection tells us, let us try to solve them. Solving 1 and 2. We can just subtract. 1 minus 2 implies mx minus x. Y and y as I subtract will get cancelled. Minus 3 plus 6 equal to 0. Or I get m minus 1 into x equals 3 minus 6. Or x is equal to minus 3 by m minus 1 or 3 by 1 minus m. The condition is the x coordinate should be an integer. X needs to be an integer. What does it imply? The numerator is 3. Denominator can be either 1 or 3. So that 3 by 1 is an integer. 3 by 3 is an integer. So the denominator can be either positive or negative. So the values can be plus or minus 1 or plus or minus 3. What is the denominator? 1 minus m equals plus or minus 1. Minus m equals plus or minus 1 minus 1. Or minus m equals 1 minus 1, 0. Minus 1 is minus 2. Or m equals 0 or 2. The second condition, 1 minus m can be either plus or minus 3. Minus m equals plus or minus 3 minus 1. Or minus m equals 3 minus 1, that is 2. Minus 3 minus 1, that is minus 4. M equals minus 2 or 4. So what are the four values we get? M is 0, plus 2, minus 2 or 4 for x to be an integer as well as m to be an integers. So let us write for x comma m to be integers. The four values of m are 0, 2, minus 2, 4. Putting them back in equation number 1. What is the equation? Y equals mx minus 3. So we get y equals 0x minus 3 or 2x minus 3 or minus 2x minus 3 or 4x minus 3. Rearranging the equations, we get y plus 3 equal to 0. 2x minus y minus 3 is 0. I can bring it to the left. 2x plus y plus 3 is 0. Bring y to the right. 4x minus y minus 3 equal to 0. So these are the family of lines which satisfy the given condition. Hence the problem.